Afternoon, we are now live.
Good afternoon. Welcome to this webinar organized by the FTTH Council Europe. My name is Vincent Garnier. I'm the Director General of the Council, and I'm very happy to host this session today titled Proactive Service Assurances with End-to-End Quality Monitoring. And this topic is brought to us by our member and partner for today, Icotera. So let me first, before we get into the presentation of the session itself, let me first give you some information. Kim, you can bring me to the next slide. Some information about the FTTH Council. For those who are not familiar with our association, we were created in 2004, with a mission to promote a full fiber network as the most future-proof and sustainable access network technology. We have 170 now member company, part of the council, vendor, operator, investors, the full spectrum, the full ecosystem around the deployment and adoption of fiber. And we run many activities, including in-person conferences, but today you're part of this online webinar series. And I'll show you on the next slide a few housekeeping items. We will be recording the session. The replay will be made available for all the live attendee and those who registered. You can also ask questions, which will be taken at the end of the webinar by our panelists, using a specific question box you can access via the control panel of this platform. So don't hesitate to ask questions, even those we are not able maybe to take during this 1 hour will be forwarded to our partner and answered individually. So without further ado, let me introduce you to the topic, which should appear on the next slide. And maybe the best introduction from the perspective of the FTTH Council is to tell you that we are really focused on promoting the rollout, but more importantly, the adoption of fiber. And one of the key parameters driving adoption is clearly customer satisfaction. A lot of that satisfaction from a subscriber standpoint is connected and is linked to the quality of the service in-home, the quality of the connectivity. And for that, it's important that operator and internet service provider have a good monitoring of that connectivity. And I think this is really the topic that Kim and Eric will touch during this hour, how to have remote diagnosis, how to generate quality data to understand the service quality, and how to monitor that service to maintain the highest level of satisfaction. Now, our two speakers are from Icotera. The first speaker will be Kim Esben Jorgensen. He's CTO. You will cover, Kim, I think, the most technology-related part of the presentation. And Eric Pedersen, who is SVP Sales at Icotera, will follow with a perspective maybe more from the customer standpoint. And with that, I'll leave you the floor, Kim, for the first part of your presentation.
Thank you so much. So we named the webinar today Proactive Service Assurance with End-to-End Quality Monitoring. And we are very excited to give you an insights into what we see are key capabilities in the PON network, in your fiber infrastructure network. We will not be going super deep on the technical side, so do feel free, as Vincent said, to ask questions if you want to do that, and we can also have sessions separately afterwards on specific technical topics. So any good story tends to start with a problem of some sort, and I'm in luck because network operators have many of them. I would like to present 4 for you today, but before doing so, I would like to talk and clarify on who are the network operators. When we say network operator, we mean the entity taking care of the passive infrastructure and the active infrastructure to the extent of what is the demarcation point in the household up until and including the OLT in the central office. So you end up with a passive plus an active part of the network as a transmission network, but not supplying necessarily at least any services on top of that.
Yeah, and then over to me. So some of the challenges that we see, and we pointed out four of them, is as the first one, the deployment costs. So if you go to the next slide, Kim. So basically what we've seen over the last couple of years, and which is probably normal due to inflation and so forth, but definitely the cost of capital have gone up. Interest rates have risen. I know that it's in some places they're going down, but overall, it's been more difficult to raise funds for network operators, and which you could say in many places lead to the fact that building homes passed have switched more towards homes connected, which for us is good because we provide the active equipment here. But for those that operate the networks, it's definitely an increased cost of basically managing and running the network for their customers. We also see in the EU that there's a lot of focus around ESG. The green profiles is quite critical for many vendors, and that also drives cost upwards. And as you say, salaries have increased, overall, you want to avoid truck rolls because truck rolls are expensive. When you've deployed the network, you want it to run, and you want to make sure that it's providing the service that the customers are looking for. So that combined with the inflation overall means that deploying an individual home, not because maybe so much about the equipment, but the costs around financing the equipment and bringing it out to the customers has increased from a cost perspective.
And the second problem we defined as uptime and service quality pressure. And to dig in on that, we see that there are very, very high expectation from the customers, that being the end users, but because we're talking about a split model with network operators and service providers on top, also naturally from the service providers. And what is a high quality network? Well, this definition has changed over time. It's clear that it's very high uptime, and the telecom nines are often put in place. 4 or 5 nines are definitely expected, if not more. And the same thing at the same time, also very, very low latency required for gaming and many other services. And the customers are becoming much, much more aware of these things now, actively measuring the quality and not just the speed, but actually the quality of the network. And because the ISPs are being forced to deliver better and better services, they are obviously optimizing their infrastructure, they're improving their peering points, etc., to ensure low latency. They are also putting very strict requirements towards the network operators. They're doing strict SLAs as to what can be accepted and what not. And these things are, at least they tend to be, monitored automatically. And when the customers finally complain, even if it's over small service level deviations, it easily costs anywhere from 15 to 120 minutes per incident to resolve, calling for level 2 or 3 technicians to go in and troubleshoot the issue. And we'll come back to why that is extra complicated on a PON network, spending the time, energy into understanding the case, after which many of those cases tend to be a, hey, yeah, but it's not my problem kind of answer, right? And for the resolution is somewhere else. And furthermore, in many of these cases, the problems are never resolved, leaving the customer in a bad situation.
And then you could think, back to my first point, as costs go up, that prices would go up as well. And for many reasons, that doesn't seem to be the case. So what we see is, and there are a couple of drivers for that. The first one is obviously that there are incumbents that are having cover they want to earn out on. So basically, they want to keep the customers on that technology as long as they can. And how do you keep people on the technology when you have a much better technology as fiber coming in, competing against you? Well, you reduce prices. We also see that, and that drives fiber for sure. We understand that when you want to provide mobile networks, and we especially see that where we have basically homes passed or at least fiber rolled out to a large extent, as in the Nordic countries, that the quality of FWA networks increase, and as many have paid expensive licenses for these, they want to get as many users on as possible. And how do you get many users on? You take the prices down. And then you could say that from a competitive point of view, as fiber has become deployed more places, many network operators are being forced to open their networks. And when you open your networks, you start to have an equal compare between other network operators. And equal compare means that you're also getting under pressure. So what we actually see, if we look at it over the last 6 years, we can actually see that year over year, the pricing that you as a network operator are able to get for your service is actually reducing by 5%. So that's not really an optimal situation when you think about the cost of capital, the cost to operate a network is increasing, but at the same time, you aren't able to get the same amount of money. It was a better world when, at least from a network operator, when you have the full service stack and you could set your prices on the basis of that. Now you have to compete with other network operators because people compare service providers compare what the service cost in various areas. And we see some level of overbuild as well, also putting pressure on these type of things. So overall, it's harder to get money for your service.
And the fourth and last challenge is about the standardization. So we know that no two OLTs are alike, and that's because the northbound API standardization is simply missing. And we know that there are solutions like FANS and SEPA and other things that are pushing out for disaggregation on the OLT side, on the central office side of things, that does define some standard ways of making these devices talk together. But at the same time, when the industry is considering 3 different standardizations for how to solve these problems, we cannot really talk about standardization, can we? Engineers, technicians, they tend to use the command line interfaces for even the basic troubleshooting, which often requires certification or additional training from the vendor side to be able to just do the basic things. And we see that the OT management systems, the ones that are in place, they are from the little bit larger telcos that have created a homebrewed solution. They are troublesome to maybe not to operate because they tend to be custom built exactly for the use case the network operator ISP might have, but at least they are difficult to modify. They're difficult to manage in a sense of adding additional feature set or bringing in new OLTs. And then we know that the southbound standardization, so that being the one that goes from the central office OLT to the customer side on the ONT side, that's very well defined. We have very strict standardization here, defined greatly by the ITU-T. But at the same time, it's also quite simple and requires vendor extensions. And all of these vendor extensions, because of the simplicity on one side and the tool of vendor extensions on the other side, we end up with implementations that break this standardization. Many basic features becomes vendor extensions, becomes vendor proprietary implementations. And then it forces these vendors to because of this complexity, it forces many of the vendors to adhere to a very, very basic feature set or complicate the IOP process, if not. So it tends to be quite simple feature set we see. And at the end of the day, because of the cost of doing something else. Vincent?
Yes, so I think I'm going to launch the poll, which is directly connected to the question you shared. And so the question to our audience today is, which of these challenges which have been described would you rank as the most significant for you? So I repeat: A, deployment cost; B, uptime and service quality pressure; C, service prices which have stagnated; and the last one is limited standardization. So I can see that quite a lot of you have already started to vote. I will. It's quite balanced, I must say, for the time being. So I think you must have convinced the audience that every single of these 4 points are very relevant. Let me give our audience a few additional seconds before I share the result. I think a good half of our audience has already voted. Situation seems now to be stabilizing. So in the interest of time, I will end and share the result. And what you see, I think it should appear, is that at least deployment cost, service quality, and limit standardization seems to be the most critical pain points according to the audience. I don't know if you have any comment on that, Eric.
Yeah, I think at least it's good news that those numbers we see on a global level doesn't seem to hit as many in terms of the service prices and stagnation, but surely the deployment costs are critical, and the uptime, delivering the uptime is absolutely critical. But I think, Kim, and you'll come back to that, the limited standardization, how to cope with that is quite good. So it seems, as you say, that's why it's quite balanced, which is good, because we're going to try to see if we can solve them all, or at least not the services costs, but we'll get back to that.
Okay, and maybe let me, before I give you the floor, Kim, let me go just remind our audience that you can use the question box. Don't hesitate to ask questions to make sure that we have a very rich discussion at the end of the session. So closing the poll, and I give you back the hand for the slide.
Thank you. Yes, very interesting. You sad and depressed now with all these problems from before. Then I'm here to say I don't think we have to worry. So at Icotera, we started the journey of the proactive monitoring, troubleshooting and monitoring more than 10 years ago. And we've been bringing solutions to some of these problems to the market across our portfolio. And the solutions that we brought to the market in the past, we believe many of these techniques can help the network operators and the telcos also today. So a bit of a journey. So if we imagine a world where the ONT goes beyond the standardization and becomes capable of more than just forwarding frames. It's important to keep in mind, because we are coming from a world where the ONTs, the fiber termination device installed at the customer's home, had just one purpose: to take traffic in and traffic out of the customer's home, and do that in a very energy efficient way. The latest generation of ONTs, they are, on the other hand, because of modernization and chipset capabilities and using new manufacturing techniques, they tend to be, at least ours are, equipped with very advanced gigahertz ARM processors, so very, very capable solutions, tend to be dual core, if not more. And in the context of a fiber termination device, they at the same time have an abundance of memory and flash. We're talking about very small, very power efficient devices out there that have the capabilities of doing much, much, much more than just forwarding packets. So we keep that in mind when we're talking about and how to use those capabilities of the ONT. If we are thinking about the ONT as a device that now monitors the traffic flows and its general state, whether it will be towards the customer or towards the central infrastructure, and manages that situation and its capabilities beyond the limitations of the OLT. With that, I mean, without being limited to that standardization we see on the ITUT defined OMCI layer, so the standard management layer between the ONT and the OLT. What if we can do more than that? And where the ONT can manage the complexity of some advanced protocols and monitoring tools. And here we're going to talk about the TR069, CWP, and also future standards with very extensive data models, collecting a lot of information, a lot of details, and making that available to the network operator. And why the point about the industry standard tools is so important is from the standardization topic before. It adds, of course, a lot of value to bring in yet another protocol, yet another way of monitoring it. But if we are to make this truly implementable by the network operators and the ISPs, we need to give them tools that they are familiar with in formats that are well standardized. We have solutions for that. So solution is more power to the ONT. We have 3 innovative features that we would like to present to you today. First one we call the customer service testing for effective remote service validation. This is the concept of the network operator, the management entity at least, of the ONT being able to schedule a fast speed test. That could be the TR143 that we are implementing first, but later on also 471, for example. Making that test on the cost profile of your choice on the ONT. So these, and I need to explain that a bit more. So we traditionally see this protocol being used on routers, customer routers. It comes from the broadband forum. Their focus is the whole infrastructure, but started really out of, and that service started really out of the capabilities on the routers and how do we validate the customer service. But we're taking that, let's say, service validation, and we're putting that down on the ONT, making it an infrastructure validation, right? And on a modern ONT, we're able to saturate the PON link, XGS PON or GPON link fully for these very short speed tests. And they can be executed, they can be started in different ways, they can be intrusive or not intrusive, depending on the service understanding we would like to have or the infrastructure understanding we would like to have. And with the right network design, these speed tests, they can also be done outside the network operator's network. So we could do the testing from the ONT, we could inject ourselves in the service pipeline, and we could do a testing towards the ISP infrastructure, thereby creating a feeling of the customer experience without touching the customer router. And why is that important? Well, it's important for the troubleshooting part. You start wide and then narrow down, or you start narrow down and then go wide. Without having this capability on this central part of the infrastructure, it's really difficult to understand. And providing this to the ISPs as a, let's say, looking glass kind of feature, it allows ISPs furthermore to conduct this kind of service assurance testing themselves. Okay, the ISP sees a service degradation between their router and their infrastructure. Now they have a chance to dig in, zoom in on that, and understand what is the situation between the ONT and the network operator's infrastructure and my own infrastructure. So thereby narrowing down where the problem could be. And the resulting report here can document the network quality, the service level, without thinking about the home infrastructure. It could be a poorly operating, functioning router, for example. It could also be the cabled infrastructure. If we're looking at how that looks like in a simple diagram here, we have the ONTs to the left that are connected to some kind of OLTs. It tends to be a bit of infrastructure in between. I narrowed it down, made it very, very simple. And later on, we have data centers, we have exchange points, X1, X2, again, some kind of infrastructure before we finally connect out to the ISPs. And some example, it might be a bit extracted example here, but thought example here, but but it tends to be an infrastructure more or less like this. So now we have the ONTs, and they're capable of TR069 and TR143, and we can perform these infrastructure agnostic service testing, and we can terminate those tests at the central data centers, the central infrastructure. That could also be on the exchange points, mind you, or directly towards the ISPs again. We can perform two-way testing. It's very important to remember. It's also part of the 143 standard. So we can test the upstream and we can test the downstream. And we are not just validating our own infrastructure. It does require a bit of configuration, but our software have the capabilities of allowing you to do that. It all depends on the use case. And you can document your end-to-end service quality, thereby giving service assurance to the ISPs and increasing the customer experience, because now we have the full insights into how the network is operating. And there's a lot of fine details, of course, to the implementation of this that I would be happy to discuss. But we see a number of different ways of doing this. So these tests can be run either at will when there is an issue. As I mentioned before, it could be a looking glass feature to the ISPs as well, but it can also be scheduled to run at certain times. It can be run as a non-intrusive, a high PPS packet per second kind of test using the same tool. So it can be executed where we try to consume as much bandwidth as possible. But for the example here, the focus is to understand, is there enough capacity available for my customer? And of course, that is the primary parameter for many of the customers, because that's what they're measuring, isn't it? That's their speed test service. The second feature is something we call continuous service monitoring. And the key point of this is because we could do the same thing using the previous test. But what is different with this concept is that it is low cost, and I'll explain that. So low cost and continuous monitoring for customers with problematic service history, or all of the customers. So the idea here is that we do constant service monitoring. So we always know in great detail what the customer could expect from the network. So we can do that by monitoring some of the advanced metrics in the dynamic bandwidth allocation of the PON network. Similar features could work in point-to-point or active Ethernet, but our focus here is really on the PON because shared bandwidth. We can understand these advanced metrics of the PON link itself, things that are not being made available via OMCI because of the limited standardization issue before. And we do that by using either OAM features that are available on some ONTs, they're available on ours, or multicast. And the later example is going to be around the multicast. So our ONTs can work as monitors of the multicast stream, and we use the constant multicast stream to validate the quality level. And we do that without adding any measurable network overhead. Well, let me try to explain that. Here we have the same network diagram, the same infrastructure as before. We have two streams that are running, one from data center 1 and the other one from ISP B. We could have these from any parts of the network. Those multicast streams, we have to understand, they could be IPTV, but for the sake of this example, and because of that is the reality in most of the networks, multicast is not used to transport so much IPTV, at least not to the end customers anymore. It's for other parts of the network. So in this example here, we're talking about generated multicast streams that contain a simple UDP and RTP header. So we have the continuity understanding. Are there packets missing in my flow? And we have the packets of a certain size, so they get matched, and cost and DSPF, of course, parameters. So we assure they are being tagged and marked by the cost correctly throughout the network. Right? Small packets, big packets, it doesn't really matter so much, but it depends more on the cost profile matching here. And those streams are then reaching the ONTs, and the ONTs are monitoring these streams. So the multicast monitored enable ONTs, they are receiving these multicast streams, they could reach the customer. We had scenarios where we let that multicast even be forwarded beyond the ONT. We could send it all the way out to the access point and run similar feature set on the access points. And I'll come back to later why that is a good idea. But we let that multicast flow. And because it's not that many packets per second, it could be 10, it could be 20, it could be even 100 packets per second. And because of the little complexity with these kind of frames, it adds very, very little overhead to the ONTs. And because it's multicast, the bandwidth is only consumed once, as in each of those points would be duplicating the traffic to the links where it makes sense, but the central links would not be overloaded. And because the PPS is very low here, the total load on the infrastructure is very limited. So that stream then goes to all the ONTs, and that means now I have direct comparison about my customer A versus customer B, because they're receiving the same packets coming from the same place, the same multicast streams coming from the same place, or from many different places, really. Yeah, and I can now compare the user experience between my ONT in that city versus ONT in that city, and start to understand when I have things like jitter, when I have packet loss, that in jitter packet loss could be the same depending on the delay of the jitter or the mean packet arrival times. I can understand everything necessary to get a better feeling of the service quality beyond that of the speed test, because the speed test shows me how big is my pipe, how much data can I get through at that exact point in time, but not how my very important low bandwidth services are functioning in general, and if there is packet loss on any of those services. That needs to be quite severe before it will show up in the speed test. And by letting that stream, for example, continue to the router and to the access points, we now get a full understanding. So we can see not only from the ONT's perspective, how was the quality of the stream when it reached the ONT, but by taking it to the router, we can see what are the service degradation on that step, the next step between the ONT and the router. And by sending it over a wireless network to the access point, we take it one step further. We get a full understanding of the customer's wired or wireless infrastructure as well. And one could think it further and let the mobile app even receive the same stream. It doesn't need to be multicast. Multicast is just a good way of transporting this data. We'll support other means. Keeping the PPS low and the number of devices being monitored to a reasonable level in the infrastructure, we are talking about an almost insignificant amount of data being used to get this detailed insights. So what do we need? We need, of course, to have a multicast enabled infrastructure for the multicast part, as it can be OEM or it can be also a unicast based stream. And as I said, we're streaming it from central points in the infrastructure. We have thin containers that you could deploy as a little VM that generates this stream, but there is no magic to that. It's a few lines of scripting. That's more than enough to get the flows running. And it works across any infrastructure because of the simplicity of the stream of the packets. Again, it's important to be sure that we are marking this correctly so we get the right cost levels. And on that note, one could run multiple streams with different cost profiles at the same time to get an understanding of the cost profiles across the scene. So again, the big difference between the first and the second was, well, the first one is to check how big the pipe is, how much data can we push through. The second one is more, what is the quality experience of that link? And that paired together with some metrics about the optical levels and about the dBAs, etc., will give you a better understanding of the quality experience that could be expected on the customer side. The third one is something we call self-certification. That allows the operators to get a better understanding into how the ONTs are configured by the OLT, because in our setup here, we are talking about the traditional OLT setup without the disaggregation, but it's also very relevant in a disaggregated PON world, where we from the ONT perspective are getting an understanding of how these devices, they are configured. That is information the ONTs have today. It's existing on all the legacy devices, right? But this information is not shared with the network operators. the OLT is sending some configuration, and we're expecting the ONT to understand this correctly and get the best out of it based on the standards and behave correctly, right? So what we are giving here is we are giving the network operators, the managers of these devices, we're giving them insights into how these ONTs are configured. It allows the network operators to monitor, to understand how the OLTs are configuring the ONTs, and I'll come back to that, compare how that configuration profile looks like between changes in the central office infrastructure. So it gives, you can say, full documentation to the network operator. Not only you know how you configured it on the OLT or your virtualized OMCI stack, but you see also how that is being interpreted by the MIPS that are being sent from that infrastructure to the ONTs, how that is being interpreted on the customer premises side. And that allows, again, the network operators to pinpoint the issue without using costly equipment for analyzing or decoding that OMCI. It's a simple way of extracting very vital data. And if I'll try to do a brief explanation here, say that you're a network operator, and network operators, you need to, from time to time, update software, line cards, etc. on central infrastructure, but the customer premises devices, the ONTs, tend to stay. Eric, there's a lot of echo coming from you. Would you mind muting?
I'll mute.
From time to time need to update line cards. They are going end of support or update software because of security issues or the likes of that. So imagine a world here where we have any generic legacy XGS PON ONT, and on the side we have the Icotera XGS PON ONT. And when we're upgrading the software here, version 1, 2, 3, and model X, Y, Z, when we do this validation, we have to do a certification of that. The first time we need to do a certification on both. We need to get a detailed understanding of how those devices are operating, but because we are getting the full and detailed information from the Icotera entities, the subsequent changes on the OLT side means that now we can just do a simple comparison between the ONT's understanding of the configuration between the previous software version and the next software version. We can simply do a diff on those two configuration files, if you will, those two overviews of the configuration. And if we see that there are no changes, then we understand that, well, since we're sending the same thing and the ONT software didn't change, we are expecting the ONT, rightfully so, to interpret that in the same way. And the certification process is done. Whereas the other one being a black box, we have to do full service assurance, validate all the parameters, and even simple changes sometimes on the OLT, as in like the order of how you run those configuration commands can significantly change the output on the OMCI level, the output being sent to the ONTs and causing a different effect. Now we can compare this in all the scenarios, whether it will be a bringing up or bringing down or changing service level at a customer. And when we finally move on to the later software and we're still doing the manual certification on the generic ONT, we can rely on the self-certification on the Icotera ONTs, where we see the mismatch clearly by comparing previous configuration to the new one, where we can see the mismatch, and we see that early. The moment we connect it and take out this data, all the needed details are available to quickly understand what is going on here on the ONT. What is the status of the ONT? How is it understanding the configuration? And in the worst cases on the generic ONTs, those little changes in behavior on the configuration side could be issues that can be missed, because it could be corner cases, it could be deprovisioning issues or reprovisioning issues that we do not face until these devices are already deployed and it get caught in the field, right? So this is a very simple tool, but a very powerful tool, where we are letting the ISPs, without running any kind of special debug software, allowing them to take out this configuration data and doing their own comparison. We also have some interesting IOP tools that we're giving to customers who are testing on combinations of software line cards and OLTs, or maybe special VMCI stacks that previously haven't been tested or validated, or special configurations that haven't been seen before, to allow the network operators together with our team to quickly validate these and get them certified. And we tend to see that any certification on any type of OLT can be done in a matter of a few days. But with this step here, we can do it even faster. But not only that, we are also allowing the network operator, we're giving the network operator more documentation. So when there is an issue he needs to clarify, he can easily go either to the OLT vendor or the ONT vendor and say, here's the data and this is what is happening, and that needs to be fixed like this and that. So a really powerful tool for the troubleshooting. Vincent, I think we prepared a poll here.
Oh, sorry, I didn't see the slide for the poll, so I wasn't ready to launch it. I think that's the case now. So your question is, which of the following features are most compelling for you? Customer service testing, continuous service monitoring, or self-certification? So this is where you discover, Kim, where you've been the most convincing. I can see that close to 40% of our attendees have voted. Well, I don't want to spoil the result, but I think one is taking the lead. I give another 20 seconds to our audience. I think I can end and share the result now. And as you can see, continuous service monitoring seems to be the one taking most of the interest. Any comment? Does it match with what you typically see among your customers?
I'm not surprised. You can continue, Eric. I'm not surprised, right? The bandwidth is important, but at the end of the day, what gives the good experience to the consumers is that we are continuously delivering low latency, high quality connections to the customer's home. Bandwidth might be what the customers are monitoring, but we also see more and more, and as these services and these tools for testing are evolving, we're seeing a much bigger focus on the low latency, reduced jitter, etc. So I'm not surprised. It's also my personal favorite. Eric?
Yeah, it would be pretty much in line with what I would be thinking and what the customer dialogues we have actually indicate as well. So good. So maybe we go to the next chart. So how are these products, how are these services available? And I'm not going to go through a full product portfolio overview. You'll see that when you get the charts sent over. But what I want to highlight is we generally have two type of portfolios in our fiber termination ONT lineup. That's either patch-based or FTU-based. And what we mean by the FTU is that the fiber is encapsulated in you could say, in a back plate where you can slide on and do some level of do-it-yourself upgrade, or the customer can do some level of do-it-yourself upgrade, or you can have a technician send out without having to splice in the home when you exchange, for example, from a GPON to an XGS-PON device. And the difference between the various numbers here, between the FX310 and FX410 and so forth, is generally just the port configuration on the products. So we have these products, these features available for our XGS-PON portfolio. But interestingly, as well, is if you go to the next one, the next chart, Kim, is that we actually have it lined up for the GPON portfolio as well. So for those that run a mixed network, you would be able to use these features both on your 1G and your 10G customer infrastructure. And whether you then choose an FTU-based or a patch-based solution is more of how you build your network and how you implement it in the home. We see generally the FTU being something that's being used in the Nordics, whereas we see other countries using a more patch terminating in some kind of a generic FTU, and then patching into the ONT. We support both things, and we support it both on the GPON and the PON portfolio. And then just before we go to the questions, a little bit about who Icotera is. So basically, we develop and manufacture standard setting FTTH and CPE solutions. So basically, we are a European company. We have our development, both hardware and software development in Poland. I'm here headquartered in Denmark. So we had, when Kim founded the company some 17 years ago, it was a Danish company, but it very fast moved into everything being developed in Poland, and that's where we are today on 3 different locations. We don't only do fiber termination. We came out of the FTTH world, and if you go to the next chart, Kim, we today offer a fiber termination portfolio that we've spoken about today. We offer Wi-Fi routers, Wi-Fi 6, Wi-Fi 7 routers, generally powerful, because we believe that when you bring products into the home and you provide fiber infrastructure, you need powerful Wi-Fi. Otherwise, you're not satisfying, you could say, the needs of the high speed you're providing into the home with the Wi-Fi solution that you're bringing out. Of course, as you could say, is an extension of these routers. We have various access point solutions based on standards. And then when basically to put all of this together, we offer this with some value-added services. That could be customization of products, very bespoke built products for the individual network operator or service provider. It's third-party software. We are moving more towards open software stack with Purple in the future router setup. So you can implement your solutions on containers, have your own web UI on as well. We focus a lot around ESG. So refurbishment services is some of the things we offer, but maybe even more important, the products that we build are basically built for refurbishment. So an example of the new Wi-Fi router portfolio is we generally see when we do refurbishment, around 10% of the units that come back are scrapped because they're scratched, or somebody's been having them in a space where they've been colored because of smoking or dust or other things. And actually, with our new router portfolio, you're able to exchange the shells on them. So you can use the expensive part, and you could do that yourself, or your partner can do it, or we can do it for you. So we try to add these services on top, and those services we just spoke about is one of those value-added services we try to add to the portfolio for you to be able to differentiate what you're offering to your end users. And if you go to the last chart before the questions, Kim, you of course can reach out to any of us after if you have specific questions, if you want to have a dialogue around, if you want to discuss products, solutions and pricing and so forth. You can reach out to Kim on the technical side, or to me on the sales side. But I think, Vincent, back to you to handle any questions that come from the audience.
Yeah, absolutely. Thank you, Eric and Kim. I have one question popping up now, and I'm reading it. The results of the multicasting approach can also be used to forecast potential service outage or degradation that may be caused by physical medium imperfection or damages. And the question is this a correct assumption, or any comment on that segment?
Absolutely. I mean, you could start to see that clearly on the service degradation. Although we also have the optical parameters made available via the data model, and monitoring that carefully, and over time gives a really good insight into how it's operating. The same thing with the bias voltage, etc. The optical side can determine the over time degradation of as it's trying to maintain a reasonable service quality level, can also be used to determine if there's something going on the infrastructure side or the hardware side of things, right? And the optical levels. But yes, the whole infrastructure and the load of the infrastructure, and you tend to see problems on the jitter and the inter-packet arrival time and so on. You tend to see that before you're hitting those 95 percentile of load on your links. Yeah, so it's important to have this kind of insight, and the ISPs tend to have that on the infrastructure, but taking it all the way out to the customers where we really add value. So yes.
Very good. Another question: can existing legacy devices be upgraded to support the new feature you presented?
Well, to some extent, some of the things are available on legacy or OEM, tend to be, at least on some. We have it on our legacy products, but it is very much linked to those newer chipsets, the third, fourth generation chipsets, and the extra capacity and memory and flash and processing power that allows us to do that. So I would say in most cases, probably not the full extent of these services, unfortunately.
Okay. Third question I read: do you have separate application to monitoring ONTs or remote configurations?
Yeah, we're working in general. Since we're basing this on open standards, we're allowing ISPs and network operators to integrate this as they see fit, and it could perfectly fit into their standard ACS. Just another device connected where you can monitor this actively or passively. But we're also working with a partner to create a full end-to-end solution, so a better integrated experience where this becomes part of a dashboard. This speed testing and the service quality monitoring becomes part of a dashboard that the ISPs can access. So network operators can access in the case they might not have infrastructure available or wish to segregate, you can say, the services with the infrastructure part. So this is something that we would like to demo to customers over the next weeks here.
Yeah, I'm just trying. I'm a little bit overwhelmed with all the questions coming up. Let me take this one. Assuming that these functions are deployed as software agents, could these be deployed into non-Icotera ONTs? Well, and I have in the bracket perhaps as TR-369 container apps.
Definitely so. There's some details, right, about the exact implementation, but taking the approach of deploying containers, then absolutely so. The code for analyzing these streams is not complex. We could easily deploy that as containers, and that would fit well into the Eric mentioned before, Purple and the LCM containers. That is our strategy for our routers. That would fit very well in there as a container application. Absolutely. When it comes to the more embedded type of devices, then infrastructure, or if you say the integration on embedded devices becomes a bit more complicated. The legacy devices tend to be locked down, secured. So it really depends on your operator. And that's why one of the things we spend a lot of time talking to our customers about is the importance of signing agreements that ensures these devices will continuously be updated for a very long time, continue to get relevant software, and when such is not possible, having them opened up to an extent where it's possible for others to deliver the relevant services.
Okay, I have actually two questions on prices. There is a blunt one. What are the prices of basic ONT you produce? I'm not sure you can answer that immediately. And there is another one, which is, does the service come as an additional cost? I mean, the service you described, the specific feature you described, that how does it come in price-wise for a network operator?
Maybe that's for me to respond on the specific prices. I would say generally we see that this is not something that drives additional cost. So pricing for these products is, I would say, should be in the range of what people are looking for when they're looking for a GPON or XGS-PON device. In terms of the additional cost, obviously to set this up and make it work, you need to have a provisioning system to capture the data. So there's a cost related to this. But at this point of time, these services is something that comes as part of our ONTs. So we are not pricing this on top or pricing it up, because we believe that this will drive, that's maybe we're naive, but we believe this will drive sales of our ONTs. And that's the business we're in developing and selling ONTs. And then we want to deliver this service simply to differentiate our products in the market, even though being based on standards. So on the specific question for a quote, just write to me and I'll provide that.
Okay, perfect. I'm just wondering, what is your advice to your client on how to best integrate these features? How can they capture, practically, operationally best integrate them, and how can they capture the most value from these?
I touched on it briefly. So you could run this in an active way, schedule tests from time to time, or let it in a more, let's say, in a more troubleshooting way, run these services, execute these tests when problems appear. So kind of see both putting them into a system that is scheduling the execution of the speed test and continuously grabbing that data and putting it into a dashboard. I think that's the approach where you would get the most out of that. And that is the solution we are working on together with a partner. And again, it is all based on standards. So we are just trying to bottle this and make it really, really easy to get the most advantage out of it. But any ACS will be able to do this.
And is there a specific profile of ISP operator you would recommend this series of features and product for? Do you think that you address the entire European market, or do you see a specific profile where you think this is the most appropriate?
Well, if I would start, and maybe Eric could add to it, I think that, as I said initially, it's mostly for the network operators, where you have this tendency to this blame game of where the fault might be, and getting early on insights and understanding to the quality of the infrastructure provided and documented and shared in a clear way. That is where this the speed testing service and the quality monitoring, the continuous quality monitoring add its most value. But it doesn't stop there. I think it has value, especially because of the very low overhead. It does have value across the full scene, whether it will be GPON, XGS-PON, or in a future 25, 50, or 100 gig PON scenario. The better insights and the understanding of the service quality level is important, and there will always be a pressure on the bandwidth provided. That we know, that will not stop.
Okay, maybe a last very practical question for you, Eric. Patrick is asking, are these services available? Are you marketing these services immediately now? And maybe shall I add, because we see people connecting from all over Europe, is it geographically available everywhere in Europe?
Yeah, geographically there shouldn't be an issue. Let's make that clear, so we can take a direct dialogue around your specific need. We generally serve, you could say, the mid-size to larger service providers directly, or network operators directly, and the smaller ones through partners. But let's have a discussion around it, and we figure a solution out for the individual need. And for these features are available for testing now, so you can test certify them, and thereafter implement them. So they are available for test for those that are interested in looking into it, figuring out how they can create the best possible implementation of it.
Okay, I think we're reaching the top of the hour, which is the end of our session. Kim and Eric, I would like to thank you very much for this very interesting session. We will follow up with all participants, and of course, they will have your details, and you can hopefully continue that conversation with those who are interested. With that, I would like to thank our audience. We have a lot of webinar sessions coming down the road. You said Icotera is based in Poland. We have a congress, an important conference in Poland in 3 weeks' time in Warsaw. Please stay tuned, and you will benefit from all these insights either during our physical conference or online events. So thanks again to Kim and Eric. Thank you for your attention. I wish you a very good rest of your day. Bye-bye.
Thank you.